Hello, welcome to the next in the Asset Hub webinar series, the second. Today's topic that we'll be hearing about is Agentic Ops. But before we get started, I'd like to update you on some upcoming events and cover a few housekeeping points too. So for those of you who are joining your first Asset Hub event, the hub is focused on training and raising the profile of RAEs, research infrastructure engineers, through development of training materials, e-learning modules, hackathons, webinar series, and lots more. So we have lots of upcoming events, some of which have just opened in the last few minutes, so they're there to register for now. So this includes a webinar and a hackathon about Slinky, bring Slurm scheduling to Kubernetes. So that the webinar and the hackathon are now both open. I know that some have signed up for the webinar already. And then the hackathon, that's taking place at both Surrey and Sheffield, so two different locations. And then following on from the Sheffield hackathon, we also have a co-design day. So that will be some interesting talks and an opportunity to influence the training that we're planning. We also have a workshop in September, open now too, and that's on being agile for RAs. All our events are also advertised through our mailing list and LinkedIn. So if you sign up to the mailing list or follow us on LinkedIn, you'll hear about the new things that are opening soon as well. I'm also going to share the links for all those in the chat in just a moment. And please do share with colleagues who can join us today in case you think they'll be interested. So just also a quick note on our mentoring program. So this is in conjunction with HPC-SIG. The next RA mentoring cohort will be starting in September. It's open for applications now, and that's for both mentees and mentors. It's a really great opportunity to learn from others, build connections, develop new skills. And I'm going to add the link for that in the chat in a moment as well. Just before we start, a few housekeeping points. So you'll see that everyone's mic is muted, but if you have a question, please pop that into the Q&A box. You can also comment on questions and use a thumbs up if you're keen to see someone else's question answered. And then we'll have some time after the presentation for some questions. I'd also like to highlight that we have a code of conduct for all our events, and you can find that on the Asset Hub website. Lastly, as you leave the webinar today, a feedback form will pop up in your browser. It's just a few questions, but we'd really appreciate your feedback, particularly any ideas that you might have for future topics. Okay, so moving on to today's topic. I'd like to thank Richard Gilham for joining us to present Agentic Ops, responding to unprecedented user patterns on Isambard-AI. Richard is an AI supercomputing infrastructure specialist at the Bristol Centre for Computing, where the main focus of his role is leading the team's work on user-facing services. Okay, so thank you, and over to you, Richard.
Thank you. I shall take over this one. So hopefully that's come through for everybody.
Yeah, that's great. Thanks.
Perfect. So thank you much for having me along today. This is the first presentation of completely brand new material around what we've decided to call something called Agentic Ops. And this has really came out of a need to respond to some really new user patterns that we've seen on the Isambard-AI platform. So what I was thinking today was to uh, introduce the Bristol Centre for Supercomputing. We're sort of relatively new centre on the block, and Isambard-AI. Talk about the challenge we have in terms of agents being used in our systems and this solution that we're testing and proposing, which we've called Agentic Ops. Um, so if slides aren't moving along, please shout out. Um, so at the Bristol Centre for Supercomputing, we've built two new data centres and installed three new HPE supercomputers in the last 2 years. So we're very new and we're moving very, very quickly, and we've been establishing services at quite a pace. Of these, we have the Isambard 3 supercomputer, which is a Grace CPU air-cooled system. Is a tier 2 machine, part of the National Compute Resources. and also Isambard-AI in phase one and phase two, which is a CPU GPU machine targeting AI as well. And just to say, all of these machines, lots of power, about 5 megawatts worth of power. It's all using UK generated renewable energy. So trying very hard to do this quickly, but also do this in a sustainable way as well. Um, so to give a bit of background about where we've come from and how new we are, here's a little bit of an idea of sort of the timeline of how Isambard AI came to be. So in the autumn of 2023, the government gave feedback on Bristol's Isambard-AI proposal and said they really, really liked it. It all started with a phone call and proceeded very, very quickly. And into the autumn, into the winter of 2024, the procurement was performed for Isambard-AI. This is all about the time of the big AI summit at Bletchley Park and AI really becoming government priority. And as winter turned into spring, back in 2024, we started to recruit the Isambard team from places around the UK and indeed around the world, a mixture of people with academic experience, government experience, and industrial experience as well. And while that was going on, our modular data centers were being built, and the first of those was trained in early summer 2024, which is roughly when I started with bricks. And after that, we soon got the first of the services powered up, which included Isambard AI Phase 1, which was a small, relatively small system that we could locate alongside Isambard 3. And into the and then in the winter of last year, we started to onboard some of these early technical prep users. These were people who we knew had a really strong use case. And could act as sort of friendly critics to help us understand how the system works and understand sort of likely usage patterns and relatively small numbers of them so we could sort of work with them in a relatively sort of close manner. Then spring last year, we started to get into the first properly allocated projects. These were allocated by DSIT in collaboration with UKRI. This started our initial flow of projects on Isambard AI Phase 1. Then around about a year ago from now, we craned in Isambard-AI Phase 2 and powered on, and that was very rapidly brought up to acceptance, and the Isambard-AI service went live late summer, early autumn last year. And things started slowly, and by spring this year, Isambard-AI, a very, very large system, found itself full and very, very busy, and things were happening, which brings us to the story for today. Just to zoom in a little bit more on Isambard 3. So this was in 2023 a £10 million investment. So it is a traditional tier 2 HPC, mostly CPU, using batch. It's in a modular data center, which allowed us to build things very, very quickly, and has nearly 400 nodes of NVIDIA Grace CPU superchips. So ARM cores instead of x86, which we may be used to, and has a few other bits of hardware in there as well for people wanting to sort of look at sort of portability applications. But I'm not really going to talk about Isambard 3 today. Isambard AI Phase 2 is the big beast, which has been the headline grabber. And this consists of over 5,000 Grace Hopper GPUs, all contained in a 5 megawatt modular data center sitting in the north end of Bristol. Although we don't really think about 64-bit very much for AI. If we use that, then Isambard AI, when it entered the top 500 in June last year, was ranked number 11 in the world, which is as high as the UK has managed to achieve in quite a number of years. So it's been a very big and disruptive system. And we've also built it very quickly, as I've already said. The site was constructed from scratch in about 12 months, and we got it up and accepted inside of 2 months. And a year later, the service is very full and very busy. To dig in a little bit more into the specs, it is a very, very big beast. So Isambard-AI Phase 2 consists of 1,300 nodes, each consisting of 4 GPUs, and each node having almost a terabyte of memory, which can be one large address space. So even before we start reaching out across nodes, this is an incredibly powerful tool for doing AI research. And all up, if you combine all 5,000 odd GPUs, we're talking a petabyte of memory, all backed with flash storage as well. So really, really built um, for bandwidth and power. Really, really impressive machine and an absolute beast to visit. So last one on the hardware. We love to chat about hardware. This is what the site looks like. Um, so we have, let me get the laser pointer up. So we have, so our entrance is through here into our compound, and we have a transformer room here for our 5 megawatts of power. Inside this metal cage is Isambard-AI itself, which is contained in the modular data center, which is based on ISO shipping containers. They have hybrid cooling over the back here. Then we have a UPS to allow us to manage a safe power down if we have a problem. Isambard 3 lives in this wooden enclosure here, which was built first. So we just built a bigger fence around the whole lot. It's a very impressive facility if you ever get the opportunity to come and visit. Okay, so that's enough about the background, setting the scene of sort of the facilities we have. And I'd like to talk about the challenge that really brings us to the story today. And it's agents. It's also users as well. And this combination of humans and AIs working together is a really sort of novel new challenge. And I think we can start this story by thinking about how people have come about to use HPC. HPC or supercomputing, it's the means, not the end for most people. They want to use HPCs to achieve their real research outcomes. It could be drug discovery, it could be materials, it could be something about medicine, it could be a whole manner of different research goals. But HPC is the means, not the end. HPC is also very, very complicated, and it's very, very difficult for everyone to completely understand how to make really, really good use of these complex systems. So they need to build what I'm going to call a functional mental map. They need to know enough to help them get things done. And traditionally, the way you'd gain this would be by reading documentation, doing training, gaining experience through your career, making mistakes, finding out what doesn't work, finding out what does work, and learning from others. However, it's important to note that we can't compel a user to read the documentation. In fact, it's a very, very common issue. People haven't read the documentation, and I'm sure many people that provide HPC facilities have the same issue. And the issue is that learning HPC, many researchers will see it as a time cost, in that it's a cost to be reduced so that they can maximize their research productivity. And a recent way they'll have discovered to reduce this cost is to use LLMs and agents, which is great. They feel like magic. They can tell you how to do things. You can ask them to do things, very, very quickly, and are really huge force multipliers for the kind of things that you used to have to do by hand. However, we really can't compel AI to read the documentation either. We can't be sure that people will pick up what we want them to pick up and make good decisions. So we have this challenge that this mental map that we've traditionally had is at risk. When we look across the Isambard AI user base, we also have a very big surface area of different types of users to consider. We see all manner of the sciences represented, engineering, medicine, arts and humanities, all the way through to pure AI research as well. So the range of research sectors that take advantage of Isambard AI is huge. It's not contained to one research council, for example. It's also not just contained to academia. Initially, we started with lots of academic users, but increasingly we've had government users come on from various different government agencies, and also increasing numbers of people from small to medium enterprises, founders, startups, and people trying to do really, really innovative AI to achieve sort of commercial benefit. And these people are from all these different sectors and all these different organizations. Some have HPC experience, some have done a lot of work on the cloud, others have only maybe used workstations or even their laptops. Some are beginners who have really great ideas, and others are experts, have been doing what they've been doing for years. So it means we've got a very broad experience base to tackle as well. And also, when people get their allocation on Isambard AI, they don't turn up with a blank text editor and think, oh, great, I've got a supercomputer. What am I going to do? They're going to bring their applications and their software stacks they already have. They're not going to start from scratch. So they're bringing some baggage with them about the way in which they want to do things. So we've got a very, very diverse user base here, but it's also huge as well. On an average year, we probably onboard around about 1,000 new projects onto our services. Right now, I look when I wrote this yesterday, we had just shy of 850 unique research projects running across our services, with nearly 4,000 unique humans doing that as well. And Bricks is quite a small team. This means that there's over 100 users for every one of us. So it means that we're very, very limited in the ability for us to go and co-design and work with people. A lot of projects will only be with us for 3 or 6 months before they leave the platform. We can't build those long-standing relationships in the way that you might be able to on other services. So it creates quite a challenging environment in which to provide support. So thinking about how the story progressed over the last 12 months or so since we fully opened Isambard-AI service. So we launched the service, I think it was the 17th of July last year with a big political launch. It was on the news at 10 and everything. It was an incredible day with loads and loads of people that were really, really enthusiastic. And initially, our users were largely academic. In background for a bunch of reasons. And so generally they had quite good HPC experience, and the number and size of those projects was initially quite small. And there's a gradual introduction of people from other organisations as well. And things slowly ramped through the summer into the autumn, and things gradually built up, and the amount of usage we saw on the platform sort of had little ebbs and flows, but generally there was always spare capacity there. We were not pushing the system as hard as it could go. However, come spring this year, sort of towards Easter time, following some very large access calls run by UKRI and DSIT, we saw a massive increase in demand, both in terms of the number and the size of the projects, but also the diversity of backgrounds that we saw. And so this meant we saw a big ramp in diversity of the ways in which people do things, but also how hard people work the system. And this meant that there are a few surprises waiting for us, which we'll get onto after this. So, just to provide a bit of context of this, I'll introduce you to a little bit about the Lustre file system, which is a file system that we use on Isambard-AI. It uses something called an inode to record metadata about the data that's held. And every single file or directory that goes onto the storage is one inode. So essentially, you've got an inode per thing that people write. And what happens is we store this metadata in one location as a metadata target, an MDT, and then we store the data striped across object storage targets or OSTs. So the metadata sits separately from the data, which allows things to work at scale. When we build that file system, when the system is first put together, right in the early days, maybe even in the factory, the MDT inode count, the total number of inodes you can have is fixed at that point. So that limit is set for the entire lifetime of that um, uh, of that file system. And huge quantities of directories and small files can exhaust the inodes that you have available. And traditionally, this is something that you worry about maybe in the penultimate year or the last year of the service of a particular piece of hardware. This isn't what we found. So around sort of spring this year, we suddenly had a problem. We exhausted all our inodes. Things are starting to break. If you run out of inodes, it's impossible for the file system to write any more files. And suddenly, nobody could get any work done. So it became a very, very serious system. And from the administrator point of view, we obviously went to diagnose this as quickly as we could. And we found that a very small number of users were using an incredible number of inodes. This was completely unprecedented. We had one individual user who had 1 billion files with an average size of 60 kilobytes. They were using this for doing supercomputing. So they hadn't actually used that much space, just 47 terabytes, but over 1 billion files. And several other projects were using over 100 million files. And that simply exhausted our available inodes. So we were stuck. So as we do in a DevOps situation, we moved in and we fixed things. So the first thing we did was we imposed inode quotas that actually worked. So this isn't one of the things that you can very easily test because you need to do something fairly insane with the system to break it. And so we imposed inode quotas to prevent the same thing happening again. And we also provided documentation to help people design things. So if they have a lot of small files, for example, they could use Squash FS to keep them down to one inode, and actually gives better performance as well. And we also reached out to engage users to find out how on earth we ended up in this situation, understand what was going on. And this one user with 1 billion files, it turns out that 80% of them could easily have been deleted. They were just didn't really need them. And in fact, over a third of 1 billion of these inodes were actually just directories. There's a very, very deep directory tree which was causing all this havoc. So this was quite a big. This was obviously sort of quite a big surprise to us, and um, so after we recovered from this, we started to think longer term, what could we do? So how can we improve the technical guardrails? How can we put up a fence to stop someone falling off the side and into danger? And what tooling can we put in around that? But also, what can we incorporate into the mental map that people pick up? So people get a warning about this is a dangerous direction to go in. So think about documentation and training and things like that. So that's what we were thinking as a bunch of admins. Then it's always important to play things by the user's perspective to see how they end up in the situation. So So users, they have really innovative idea and they apply to get access to the biggest supercomputer in the UK. So they can massively scale up what they're doing. And they get awarded hundreds of thousands of GPU hours on Isambard-AI to go and do what they want to do. So brilliant. They turn up, they port their workload, they scale it up by an insane amount. And off they go. Brilliant. That's going to completely transform their research. However, the computer suddenly goes down, and then they get an email from someone called Rich at Bricks saying you've got too many files, and suddenly they're blocked for weeks on end whilst they have to work through wasting time deleting all these files. And they didn't know that having all these hundreds of millions of files was important. And to be honest, they don't really care. That's numbers of files isn't really helping them directly with their research. It's just collateral that happens with them trying to achieve their actual goal. So we have to be respectful of the user's perspective whilst achieving the administrator's goal. And so really understanding and analysing this and thinking about what we go on. And I think what really happened in this little sort of war story that I've told you here is a number of different gaps aligned. If you ever heard of the Swiss cheese model, that's one way of thinking about it. The user's mental map wasn't sufficient to keep them away from danger. Also, the tooling that we provided and the guardrails that we put in place, we found the gaps, all those different gaps aligned, and it meant that we had something go wrong. And this actually manifested very, very quickly when the number of users ramped up. So our early access users didn't get near this, didn't trip things up. It was the volume of users that contributed to this. And also there's a subtle change in the background of those users as well. You remember that I mentioned initially we had largely academic users with lots of experience in HPC, but that character changed over this year, which meant that our early experiences were not necessarily representative of what we're experiencing now. So, yes, we can beat ourselves up and say, was this avoidable? Technically, it was, but need to be really, really aware of hindsight because things that seem obvious from this end of the tunnel really aren't from this end. And also, we went quickly, and it meant we got a lot of research and delivered a lot of impact by going quickly. What would have been the opportunity cost of having the service ready, spending more time testing, and making sure absolutely everything was perfect before released to users. That's weeks and months when 5,000 badly needed GPUs weren't available. So yes, arguably we could have avoided it, but did we? But we're not going to beat ourselves up over it too much. We're going to learn and we're going to improve. So that's the main sort of motivating story that I want to tell you about Agentic Ops today. Just keeping an eye on time. Um, so we've seen other anti-patterns as well, but I'm not going to go into those in detail. So we've seen a lot of things that almost feel like denial of service attacks from our perspective of people massively ramping their usage, often using agents to do things far more quickly than was ever possible before. So we've seen the Lustre metadata server being absolutely saturated by agents designing methods um, of checkpointing things, writing to files, checking files exist many times a second, polling and essentially um, saturating the file system. Similarly, VS Code is very naughty for this. People running very large searches all the way from the root of the file system, all the way through, and that keeping things very busy, and often sometimes running multiple copies of that. We've seen people attempting to saturate the Slurm controller by polling the queue at 10 hertz, which we would prefer people not to do, please. It's quite a common anti-pattern. Other sites also say, please don't do this, but we see it happen. We've had people overwhelm the login node. For example, I've had people running hundreds of copies of PS simultaneously. The same user, my record that I've seen is 477 copies of PS simultaneously on the same login node. I have no idea why they were doing that, but it caused harm. And also, when we do see things that are causing mischief, if we kill them as administrators, they come back instantly because agents are tenacious and want to keep going. And that can really get in the way of problem isolation. So that's enough about problems. And in the last sort of few minutes or so, I'd like to talk a little bit around um, this this proposed solution, which we're exploring and working into, which we're going to call Agentic Ops. So first of all, let's frame the question. And the kind of questions that we're asking is, how can we guide hybrid human AI behavior? Because we're dealing with AIs as much as humans now. How can how can we guide them to prevent anti-patterns being attempted, provide good usage patterns, and also help us to start to identify new anti-patterns we haven't thought of a bit earlier. And it's important to remember that AI is not the enemy, but it can feel a little bit analog. It's not, it does, many will say it doesn't feel like proper coding, it doesn't feel like proper technical work, but it's there to complement traditional approaches. And I think you need to appreciate that they exist together. And the whole idea here is to build things together, connect tools, and ultimately enable sort of an ops type approach. So there's a few tools and information sources that are really crucial for this. The first is our documentation. We've worked very hard at our documentation over the last couple of years, and it's our pivotal and primary information source, not only for users but also for ourselves. Um, we try very hard. If it isn't documented, it doesn't exist. If you document it, you support it. That kind of mentality, because it's such a crucial resource. And from that, everything else that we talk about flows. Um, Over the first 6 months this year, we've updated the docs 250 times. It's been visited 65,000 times. It's doing a lot of hard work for us silently in the background. It consists of a number of guides and tutorials, very goal-based sort of pages, also reference information and FAQs as well, which are a very agile and responsive way of dealing with things that we notice. It was written for humans. It's still human first, but it can be read by LLMs, so it can be ingested by AI and is but still is that really good primary source for information. The next source of information they've got here is skills. For those that aren't familiar with skills, these are small instruction packages that can teach an AI assistant a specific skill or a task. You can provide it with an extra little boost of information and context to help it do something sensible. And these exist as Markdown files. So they're human readable if you want to. They tend to be a bit terse. They're very flexible and they're loaded only as needed. In so our documentation is actually written in Markdown. The skills are written in Markdown, so they're actually quite similar. And they're actually a really powerful way to embed local standards and knowledge into the IO's responses. So it means you can really come up with a way of telling an, uh, an AI, this is how you use Isambard, as opposed to let it work out and use its own knowledge and to do its own searching. So we have some skills for Isambard, and these are AI generated from our documentation. So this means that we maintain documentation as that primary source of information, and we can automatically generate it, but then we can augment it with anything specific that we see as well. There's a bit of a snippet on there. You can see the kind of thing that gets written. So you can see that this is telling people about not pulling the queue in some really tight loop and causing all sorts of trouble, and also provides some more useful information around good ideas and bad ideas as well. As well as those skills, making them available on the public web, we're also starting to explore putting them onto Isambard itself. Users are very welcome, and well, and they do love to install their favorite agents on Isambard. You see processes lurking on the login nodes, people running Codex and Claude, that kind of thing. We can't centrally install them. I lost track of the number of times Claude has wanted to update itself to today. So the number of different agents and keeping up with the cadence of new versions just means that we haven't got the capacity to keep up with central installation, let alone all support requests that would come with that. So we allow people to self-serve. But if people are using Claude on our systems, that provides an opportunity for us to intervene and nudge behavior very, very close to the compute, rather than people doing things on their laptops, even on their phones, and asking questions of say the Claude desktop app. We can tackle things very, very close, and indeed people running as agents on the login nodes. So what we're starting to explore is, should we force agents to pick up the Isambard skills? Unfortunately, there's no single approach for doing this that works across all of the major agents, and there's always the risk of will these get circumvented. So starting to look at taking these skills, which are derived from documentation, and pushing them onto the actual cluster, so it makes it very, very, very easy for AI to pick these up and to help their humans come up with good usage decisions. Another area that we're currently working quite actively is on building a service desk agent. Some other centres have done this around the world and with to great effect. And the reason we want to do this is being on service desk is really time intensive. When it's my turn, it's pretty much my whole week is gone dealing with those. So it means I can't do anything else. This doesn't scale to an infinite number of users. The amount of effort that human effort you need to put in depends on the number of users. The contextual knowledge that you need gets bigger every single time I come back every 2 or 3 months. There's more and more to know, which starts to stretch my own knowledge and skills in terms of being able to find out stuff and reply quickly, promptly, and accurately. And all the time that I'm spending replying to things, I can't improve services and that kind of thing. I'm I'm firefighting instead of investing in fire prevention, if you will. And a lot of what we deal with is dominated by routine or simple requests. Quite a lot are, it's in the documentation. Look here, closed. So what we're doing is we're building an agent for a first guess response, keeping humans in the loop because quality is really important for managing user satisfaction and our reputation. So we've built a workflow built on LangGraph using Claude Haiku to summarize the 2,500 tickets we've already collected and build a vector database from previous tickets from our documentation and put it into a short vector database so that when a new ticket comes in, we can get a first guess. Um, so on the right there, we've got a little bit of example of the kind of thing we get there. So you can see that um, the agent is summarizing the question, understanding the question. It's managed to search for similar tickets that have already been resolved. It uses that information, and it's able to find relevant documentation as well. So it's able to link back to that sort of context, which otherwise I'd have to go grubbing around for. It's managed to identify a likely cause and the first action and come up with some recommendations, and has come up with some suggestions about what to ask of the user. So that's something that we're in testing for at the moment, and we hope to get into early access over the summer. So bringing these different things together, we're trying to build something that looks like ops to complement sort of DevOps and SysOps. So on our diagram here, we have our information assets. Oh, where's my data point gone? There. So at the top here, we have our documentation. Documentation remains the prime source of information. And from that, we can automatically create our skills to provide more machine readable format. And we're looking on putting those onto the platform. So we provide a lot of different ways for people to get good advice, or their agents to get good advice. Then the next layer we have here, we have users or their agents. They will consume the information assets. We also have our service desk agent and the operator. They'll look at that as well. And you get that interaction between users and the service desk operator. The operator will sometimes have to go and speak to the admins to find out what on earth's going on. If, for example, there's a service issue, that kind of thing. So you've got this sort of intermediate layer here. And what goes on here affects system usage. And we can start and understanding the system usage and system health feeds back and helps administrators start to make decisions around what guidance we want to make that can flow back into the documentation and around the loop again, what new safeguards we can put in, are there any cybersecurity concerns and other things as well. So we're starting to really embrace AI as a way of nudging behavior, monitor behavior, so that we can really start to sort of improve and manage the quality of the service. So very in the end now. So I mustn't stress this work is very, very new. This is the first presentation to anyone ever of this information. Our skills is in early access now. We've got a few trusted users that are looking at it. I hope to roll it out a bit further in coming weeks. Skills in Isambard is actively being looked at the moment. We're having a tinker, seeing how it works and risk assessing that. And similarly, the Service Desk agent is also in testing. We hope to be testing that internally through the summer as well. In future work, we really want to start measuring the impact. Are users as individuals and as a cohort, are they becoming more productive? Are they not? Are they causing less impact on each other? Because on a shared system, flooring the file system affects everyone, not just yourself, like it would do on your workstation. And starting to build the information supply to really support that ops style decision making. So we're in very early days, but coming along. And that's all I wanted to say today. So thank you for listening. And that's a GH200, and that's Isambard. Thank you for listening.
Wonderful, thank you. There's lots of claps appearing for you.
Well, thank you much for listening. I went a little bit long, but
No, that was wonderful. It was great to hear your experiences, and well, I'm sure you'll feel appreciative that we're the first to hear about all of this.
welcome. Thank you for being guinea pigs.
Excellent. So we do have a few questions. One, I just wanted to highlight, someone asked about the recording. Yes, we're recording today. I will send out an email to everyone who attended or registered with the link for that tomorrow. And it's also going to go on the events page for this webinar on the Asset Hub website. So you'll be able to access it there. Okay. So we have quite a few questions. Let's have a look at through some of them. The one that came in the earliest was somebody asking about the kind of workflow that resulted in 1 billion files. Is that something you're able to talk about?
I will say as much as I can, because it's important to respect the users that had an unfortunateness, because they're doing very good stuff. They're working very, very hard. It it was not open phone, but it was a traditional HPC type application that was being used at incredibly leveraged scale, lots and lots and lots of really large ensemble simulations.
Um, Give me a quick look. So,
Importantly, we don't
Um,
look at people's stuff.
yes, yeah, and obviously I appreciate that you can't go into huge details about what individuals are doing. So in terms of your ticket system, DNAS, does it allow for agent integration or MCP?
Uh, yes, it does to some extent. We're still exploring what the art of the possible. So we use the Zamad platform, which um, is good. Other platforms are available, might be better, but yeah, we're exploring what we can do, and in terms of the opportunities there. Um, and I think as things evolve, at what point does asking where does support and looking at documentation, it'll blur into continue. It's going to be interesting to see how that evolves. But our platform will allow us to go some way, but it's going to be a while before we, excuse me, take the human out of the loop because it's so important to get the quality right. Because people are usually doing something very big, very important when they come to a large machine.
The follow-up question for that was just with that Zamad.
Yes, that was Ahmad. Yeah,
Yeah, yeah.
yeah.
Okay. Um, right. So just having a quick look through the questions. Yeah, Nina asks essentially what happens if you just tell the user that only well-behaved agents are allowed.
We do tell them that. Problem is they need to read the documentation to know that.
Yeah.
Uh, by democratizing supercomputing as much as you let all sorts of people at different career stages, different experience on, and you've got to allow the freedom for creativity. Um, and yeah, you hope that people um, really heed and the reason the acceptable use policy, which says that don't do things disruptive or reserve the right to stop you. And um, yeah, it's very much the exception that people cause disruption, and it's always inadvertent. Every single person I've contacted saying uh, what you're doing is or we think is causing a problem, they're absolutely mortified and they drop everything, work really, really hard to help us out. And I think it was the expression legislating for the 1%. It was about 1% of users that caused some of the challenges, which we've since managed to mitigate. The vast majority of users are brilliant. A lot of them we never hear from. They get their allocations, they get loads done, and they're very successful. And yeah, those that do need more support, the vast majority of times they're really, really receptive.
Okay, good to hear. You mentioned a bit about Claude. So you could run an open source model on the hardware, but is there a particular reason why Claude is chosen?
Some people choose to run Claude, some run Codex. It's what people choose to use. We don't mandate what people use. That's one of the challenges in that if we could say you shall use this, then it means that we could control it quite heavily. But for all we know, people typing into their favorite chatbot on their phone, they just on their own personal account to get some advice about what to do, and everything between sort of that very naive use all the way up to incredibly expert use of agents. Well, we don't know what we're going to get because we've got really creative, innovative, and driven users. So it's very, very tricky to sort of um, deal with that.
Okay. We have a couple of questions that are Slurm related.
Lovely bit of
So, one from Sam. Doesn't Slurm RPC rate limiting settings help combat agents who hammer scheduler commands?
yes, and we do use that. It's still good to ask people not to. We did find that we were having some issues with it. It's one of those things where it's a setting that may not have been set in the early days, and you only discover it when you ramp up usage. But yeah, we very quickly stamped on that one. It's also a very good sign. It's been a really good smell to find out how people have been using things, and you can actually get very easily demonstrate that by including or excluding the context of the Isambard docs, the the advice for my work's really urgent. When is it going to finish? You could you can get it to change that advice to using watch or not.
Okay. And then we have one from Thomas asking about whether you use Slinky with Isambard.
No,
No. Okay.
no. So
Uh,
presently it's only Slurm. We are working on providing services using Kubernetes as well, but we'll have a Kubernetes partition and the Slurm partition and dynamically manage those as opposed to using Slinky.
okay. Quick plug, just in case anyone missed it. The Slinky webinar and Slinky hackathon coming up soon. The links are in the chat if that's something you're interested in. We have a couple of questions on training.
Yes.
So, is there scope to set user training standards to solve the read the documentation issue? And there's an example from HDR UK about health data access and TREs.
Um, we've discussed it, but it's a barrier, especially with some of our users, especially from SMEs, are in such a rush that they won't stop to do training, and they will literally go, no, I'll go use another service. Um, it's something we've discussed. Yeah, it's tricky. But the problem is that we have users that are only on for 3 months, so they're going to see it as relatively excessive. I wouldn't rule out doing something like that in the future, but what, but the breadth of what users do, how do you come up with a driving test that's comprehensive? Because we'd have to teach people how to do HPC type stuff and AI type stuff, and chances are one of those is going to be irrelevant to them. So yes, we have thought about it, but this time we're not going to go near that one. But yeah, it's a good question and valid thought.
And towards the end there, you mentioned about measuring impact on users. Is that something that you've started to think about in terms of how you would measure it?
Um, we're starting to unpeel the layers of that particular onion. So at the grossest level, you could say number of node hours that have been used, but that doesn't equate to impact, and it does start to set an awkward precedent that node hours equals impact. And you don't need to throw more clock cycles at something to be necessarily be more or less impactful than something else. Um, so we're very keen to think about this. I've had a couple of informal conversations with people at DSIT who are interested in the same topic, and number of papers isn't a good measure because we have lots of people that aren't doing things that will get published peer reviewed. There are some things that won't ever go into the public domain, and some things will be have a commercial outlet. So it's going to be very challenging to work out what that looks like. I think there is secondary measures of yes, how well people are using the compute, are they using it efficiently, that kind of thing. And totally got us intern starting to look at that this summer. Um, but I think there's also things around are people disrupting each other in some of these things as well. So starting to really try and work out what can we do to help people better rather than just buy a bigger computer all the time. Is there anything we can do to help people by default make smarter decisions to be more productive? So can they get up and running quicker and use deployments that are quite sensible? So it's a difficult question. I'm really still getting my head around, whilst also doing the day-to-day firefighting.
Okay, so just to jump back to the slinky question, a self-defined cheeky question. Why keep Slurm and Kubernetes apart? Something like vCluster plus Slinky would allow for personal HPC.
Um, it's a design choice at this time. Slurm is complicated. Kubernetes is complicated to add them together, and we don't have appetite for that at this time. So yeah, fair question. But we're choosing not to look at the stinky option, and also we want to do some relatively strong separations as well for multi-tenancy. There's this whole nother talk that around trusted research environments and that kind of thing, and doing them separately gives us some good options, providing the best possible separation to support different use cases.
Um, so we have a bit of a longer question. So this will be our last question, I think, for today. So there seems to be a contradiction between users wanting and needing a traditional HPC setup, but then using agents because they don't want to spend more time to learn. Could there be a moral hazard there for the user? They can't operate without Claude or whichever model. Any thoughts on how to communicate this?
Yes, there is. And communicating it is tricky, and I think there's not one way that you can communicate in the broader sense how to use a computer that is like Isambard-AI, or indeed um, like Dawn, or indeed the NCRs and Arch do. I think you need to have multiple ways of communicating. So absolutely documentation. In fact, I wrote a documentation page saying what type of computer is Isambard AI just this spring, because people don't understand. Um, Site visits and strategic visits with research groups, that's been very effective. That outreach as well, in addition training and working on all of those is very important to talk about that in terms of telling people about how to use what we've got, but it's also on us, rather than going, you're using it wrong, make it easier to use right and adapt our services to fit with the kind of things that users want to do. Um, but absolutely, that it does feel very challenging. You've got people that come and do things in the traditional HPC sense, and they're very, very skilled in that, coexisting alongside people who are coming in very, very hot, very, very fast, and have been very, very successful using AI all their careers, and it's how they work. And there is a question of whether they are reliant on AI, but to play devil's advocate, we're all reliant on compilers, right? I can't write assembly.
Okay, great, thank you. So I think we'll leave it there. But I'd like to say thank you first of all to Richard for joining us today and his very interesting presentation and answering lots of questions.
Right. Absolute pleasure. Thank you for having me.
And I'd also like to thank everyone who attended for joining us, but also for asking lots of questions and getting some discussion going there. So we hope to see you at a future Asset Hub webinar and or event in person. So see you there.